What is value engineering in construction? So in this video, I'm going to get real about value engineering, what it is, what it isn't. So would you like to know what it should be, what it definitely cannot become, and how we can control it to the right outcome? If the answer is yes, then you've come to the right video. Okay, so let me go ahead and start out by giving you the real definition of value engineering. This is what it is. Value engineering in construction is a systematic, organized approach aimed at optimizing the value of a project by balancing cost, function, and quality. It involves analyzing project functions, identifying value-add cost-effective alternatives, and implementing innovative solutions designed to help the project meet its budget targets but keep essential features. The purpose of this is to involve all of the stakeholders and all disciplines to problem solve in a design that allows the overall total project cost to lower, but to still maintain a good quality product, again at the lowest overall total project cost, but one that can support the overall life cycle of the project. So this value engineering effort is really, in my opinion, to get rid of any possible waste, any project design that's outside of the parameters of the project and possibly the project's pro forma, what makes the overall project valuable or profitable for the owner. But it's definitely not for the purpose of enabling the general contractor to just say we're over budget and now let's cut things out of the design that's crucial that we've already fallen in love with. So that's what we're going to talk about now. So the key point of value engineering is to optimize value by balancing cost, function, and quality, and improve efficiency and effectiveness of the overall building throughout its life cycle so that we have the best possible design. But there's a problem. A lot of people have a really negative impression about value engineering, and quite frankly they should. Let me tell you what typically happens. So I'm going to tell a story here. When general contractors typically go propose on a project, they will create a CPM schedule, and that CPM schedule will be what they call a target schedule or a predictive schedule, and it's basically the demand side of the equation. It's what the owner wants. The owner wants this, or the contractor thinks the owner wants this, but in here there is not good logic, there is not good trade flow, and we are not simulating from a production standpoint what's possible on the supply side of the equation. So the project will really take that long, but we're undercutting it right here. So in the proposal phase, let me just go ahead and mark that with P for proposal. The owner, let's just make this up, was promised 20 months. Okay, all good. So the promise here was 20 months. Now we go into concept design. You don't really hear much, and let me actually say this. Probably because, and this is the story I'm telling, because the winning contractor was the lowest bid, we have now incentivized that contractor to spend the least amount of time and put the least trained people on the project, which is a bad idea because lowest bid is never overall total lowest project cost. And so in concept design, we still think it's 20 months. Great, love that. Totally good. And then halfway through, we start our schematic design, which I will mark as S, design development, which I will mark with DD, and CD phase there at the end of design. You will start to have a contractor, whether using CPM or Takt, but Takt is not the bad guy in this one. They'll start to look at it and have like an OS moment. I'm not going to say it on YouTube what an OS moment is, but you all get my point. And then they'll start to, when it's too late over here, they will figure out, oh my gosh, this is actually a 24-month project. Now, here's my question. What do you all think happens when this occurs? So I'll tell you what happens. As the designers started to work, they had this idea in their mind of what they maybe wanted the building to look like, right? Then in the concept design, they're starting to actually flesh this out and say, oh my gosh, I'm falling in love with this. Right now we're tracking on budget. It's a 20-month project, right? Okay, schematic design, they're actually starting to like flesh it out even more. We've got some features in the building. Some entryways, we're jamming out, right? We've got our rooftop units, they want a screen wall, they got all kinds of cool stuff. And then in design development, this is starting to flesh out, and now we have details, and we have systems, and we have added, and I'm just going to write down features, okay, for this building that are now fleshed out. Now we have a portion of the project that's not paid for. Here's what I'm talking about. When we said this was a 20-month project, 20 months in for the general conditions for the staff to be on site had a certain burn rate. Let's say it was 150K. Okay, so now if you add 4 more months to it, you've literally just added 600K. I don't math very good, but I think that's what it is. But 600K to the overall total project cost. And this is just a simple, small example. On a larger scale, this can be a bigger deal. Also, you have the general requirements, which consist of the trailers, the porta potties, the fence, everything else. So now you've got more. Let's just say that was 800,000. Okay, and now you've got other costs. Based on insurance. You might even have additional monies that are owed from an interest rate standpoint. You've got delayed occupancy. So you've got these like really big problems. Let's say at the end, now you've got a $3 million problem, okay? Because you estimated the wrong time here early on, and now you have your OS moment, and now it's really 24 months. Now we're going to have to start chopping things off the building. So let's just use this example here really quickly. Let's just say that we were designing a human. This is the equivalent of, okay, we can't afford this whole human. Let's chop off his or her leg. Like we're going to actually, like the entryway is gone, the screen wall is gone, the pop out is gone, the last floor is gone. Like we're chopping things off of this building to get back to under budget and really gain back that $3 million. All because the general contractor did not know how to plan the project and did not know how to schedule. So now we have a problem. We're still at 24 months if you're sticking with it, but now the building owner and the architects are mad, grumpy, and you've started off in the wrong way. Or you say, no, I want my owner to be happy, we'll eat it. It's actually not 24 months, it's 20. Now what happens? Now your project is going to be a dumpster fire inside of a burning building, inside of a solar flare. Like it's going to be an absolute nightmare because you cannot rush and push and panic a job site and do anything other than finish later. So instead of finishing in 24 months, now you're going to finish in 28. And now this $3 million is probably going to end up being somewhere around 6. But now, congratulations, the general contractor is going to get to at least pay half of that or all of it. You never know. So this is a huge problem. So value engineering means to most designers that the general contractor is going to surprise them at some time, and we're just going to have to start lopping appendages off the design. And only 2 things happen. Either you make your owner and your designers mad, or you go burden the workers and you're actually going to have a crash landed project. The better way to do this from a value engineering standpoint is to actually use the Takt Production System early on in these phases, actually know what the project will take, and know the amount of money that you have to design the building. Never let it overrun the cost, right? Really add value and design the right systems and the right building for the right quality, value, and cost from the beginning in a responsible way. So what value engineering is not is lopping off appendages. What it should be is always knowing how much money we have for this design and achieving a design that's within those targets, within those parameters. And so I know you're probably thinking, hey Jay Money, I wanted you to go like more in depth into a value engineering process and how to do it, but I want you to know that this is the first step that we got to overcome. Let's stop doing value engineering the wrong way. And I'm going to link you in the description below to a blog post and a link to our TPS course where you can learn how to do this planning so that value engineering can go back to what it's supposed to be, which is balancing the value, the cost, and the quality and the function of the building the right way with the money we have and not lopping off appendages. I hope you've enjoyed this video. On we go.